Here's a practice SAT problem. It's from the grid in section of the calculator portion of a practice test. And this is talking about a person named Wyatt who can husk at least 12 dozen ears of corn per hour, but at most 18 dozen ears of corn per hour. So what we have is at least, so I guess this would be this if they're working at their slowest pace, they're going to get done with 12 dozen ears of corn in 1 hour. And if they're working at their fastest pace, they're going to get done with 18 dozen ears of corn in 1 hour. Based on that information, what is a possible amount of time that it could take Wyatt to husk 72 dozen ears of corn? Now, the one thing that you will notice here is that the units match up. You'd have to be careful with this, right? It's 12 dozen, 18 dozen, 72 dozen. So we don't have to do any converting between, the rates being given in dozen ears of corn per hour and this just being in ears of corn or vice versa. Everything is being measured in dozen ears of corn. So that's something that we don't have to really consider within this case. What we basically want to think in a situation like this is the number of ears of corn that this person is able to husk is going to be equal to the rate that they're husking them at times the amount of time that goes past. You've probably dealt with the distance equals rate times time calculation quite a bit throughout your career in math. In this case, it's not really a distance; it's a number of dozen ears of corn that are being husked in 1 hour. But what we can go ahead and do is we can think about putting 72 in place of this number. I could put 72 dozen, but like we said, the units all match up, so we don't have to do any converting. So the easiest thing to do here is to just take the 72, toss it in place of the number. If this person is working at their slowest possible pace, right, at least 12 dozen ears of corn are going to get husked in 1 hour. If we put 12 in place of the rate to solve for the amount of time that it would take, we would just have to do this little calculation. Take the 72, undo this multiplication by dividing by 12, right? So that would leave us with 6 hours is the amount of time. So the number divided by the rate is going to equal the number of hours that it's going to take. So the most time that it could take this person would be 6 hours. The least amount of time, if they're working at their fastest possible pace throughout the whole entire time frame, then we have another situation that we can solve, right? Put 72 in place of the number, put 18 in place of the rate. 72 divided by 18 is going to solve for the time. So if they're working at the fastest possible pace the entire time, it would take 4 hours. So this is a grid-in question. There are a variety of answers that are acceptable here. You can answer with 4, you can answer with 6, you can answer with 5, you can answer with any value in between 4 and 6, and you'd have a value that's acceptable.